Hello Year 12. So today we're going to have a little look at increasing and decreasing functions. This is going to be using differentiation to figure out when graphs are increasing or when graphs are decreasing. Remember, how do we differentiate? Times by the power, decrease the power by 1. Okay. So again, a lot of this stuff here in bold, which is meant to help you, is a very, very complex way of saying certain things. So you can use the derivative, so we can use dy by dx to find out when a function is increasing or decreasing on a given interval. What that means is we can figure out, looking, obviously when you've got a graph, you can see when things are going up and when things are coming down. Obviously, if you look at this one, as you move from left to right, this thing is always increasing, it is always moving that way. Okay, it's always getting bigger. So this one is increasing for all values of x. This one starts off decreasing, it's coming down there, and then it stops there, then starts to increase to here, then starts to decrease again to there, and then starts to increase again to there. And basically the way that we do this is that when it is increasing, it means the gradient is greater than 0, so the gradient is positive. And when it is decreasing, it means the gradient is negative. Okay? If you think about it, if they were straight lines, if you made a sort of simplistic view of that one, like a sort of W, that has a negative gradient, that has a positive gradient, negative gradient, positive gradient. So what we do is we get dy by dx, or f dash of x as they're calling it there, and basically just, if it says we want the increasing bits, we set it greater than or equal to 0, and if you want the decreasing bits, we set it less than or equal to 0. Very, very simple. Okay. So show that the function f of x, x cubed plus 24x plus 3, is increasing for all real values of x. So the second it says something like this, differentiating. So dy by dx, actually sorry, I should have called that f dash of x there really, shouldn't I? F dash of x is times by the power decreased the power by 1. That's going to be 3x squared plus 24, the x will go, and the 3 at the end will disappear as well. Okay. So is increasing for all real values of x. Now this one is a little bit of a proof. Okay, this x squared is always positive. Therefore, 3x squared plus 24 is always positive. Therefore, f of x is always increasing. Okay. So that one, when it says that show that it's increasing for all real values of x, it means basically spot something like that. X squared is always going to be positive, whether it's positive or negative. So the x squared will always give you a positive number. Multiplying it by 3 will always give you a positive number. Adding 24 will always give you a positive number. Therefore, the gradient is always positive. So therefore, the function is always increasing. Okay. Right. And example 13. Find the interval on which the function f of x is decreasing. Okay. So again, find your differential. So f dash of x, notice I'm calling it the right thing this time, which is going to give me 3x squared plus 6x minus 9. So that's my gradient function, my interval, my differential, whatever you want to call it. And I want it to be decreasing, which means I want this thing, I want the values of x where that thing will be less than or equal to 0. So we'll set it less than or equal to 0, and then just solve this. Okay, so when we solve that, remember, when we're solving quadratics, don't worry about factorising it. I know you all could do that. Plug it straight into your calculator, make the calculator do the work for you. So we're going to have 3x squared plus 6x minus 9. So we get roots of 1 and minus 3. Okay, so basically this thing is decreasing between minus 3 and 1. So we write that as minus 3 is less than or equal to x which is less than or equal to 1. Okay, so if you turn over the page, you've got a little exercise there. What I'd like you to do, don't do too many of these, just do questions 1A and 1E, 2A and 2E, and question 3 and question 4. Okay, so you've got 6 questions to do there. And I'll email out the link for this, or I'll put the link, sorry, on Classrooms, to use the solution bank to be able to mark your own work and stuff like that. And can you upload it please to Classrooms? It is important that we see that you're engaging with this instead of just telling us that you can do it. Okay, thanks very much. Good luck. Any issues, just let me know.